Hi there, this is the second lesson on the hydrosphere, and what we're looking at today is the hydrological cycle and its effects on geomorphological processes. And we're going to understand how the hydrological cycle affects erosion, deposition and transportation. When we're talking about geomorphological, we're talking about basically effects on rocks, which is part of the lithosphere. So we've already discussed in class how the hydrosphere is linked with the atmosphere. Now here's a link between hydrosphere and lithosphere. The ways it does that simply is because of erosion, deposition and transportation. So we've got a big lesson today, lots of key words that I'm going to go through and explain. Hopefully you'll be able to understand the process that happen in rivers, oceans, any place where there's water and rocks. So first of all, let's have a little easy version of the hydrological cycle, the water cycle. It doesn't matter where you start. We have condensation, which then turns into precipitation, which then turns to evaporation. That's a very simple version of the hydrological cycle. Bigger ones and more in-depth ones are as follows. We can start off with the evaporation. Obviously this is caused by heat, which then turns the water into a liquid, into a gas, into condensation, and then the change in water, the changes in the air temperature then make the water turn from a gas into a liquid, and then we have the rain. And then it rains. Remember, precipitation means anything that falls as water, so it can be snow, rain, hail, fog, mist, all of that is precipitation. And then it will sink into the ground, and then it travels back towards the sea. And this is the process here when we're talking about geomorphological processes. They happen underground as well as on the land through rivers as well. As you can see here, not all rain actually goes through the ground. It runs off into streams, turns into rivers and then into oceans. Some of it is held as lakes and so on. But we do have what's this transpiration. That's where water falls on plants and then the sun evaporates the water and goes back into the water cycle. So this is a bit more detailed explanation of the hydrological cycle. Like I said, the water is constantly moving, and that's a big factor when it comes to what happens on the surface. So when we're talking about geomorphological processes, we're talking about the changing nature of the surface, and the way it does that is through weathering, erosion and transportation. What I'm going to do now is explain each of those three very quickly, and that will help you explain why water transforms so much of our landscape. So when we're talking about erosional processes in shaping our landform, we're going to talk about 4 different things, and we're going to use these pictures to highlight an explanation. So what I want you to have in your head is a river stream or a river which is filled with water, filled with pebbles. How is water eroding the lithosphere, the geology of the local area? Well, this is how it's doing it. First, by hydraulic action. This involves the force of water against the bed and the banks. And if you want to get some impression, you've got the man there holding the gurney. The gurney's cleaning the car because the force of water is taking away the dirt. And it's the same process involved in rivers, where you've got the bed. So that's I'm just drawing a diagram here at the bottom. That's the bed of a river. And then the sides, we have the banks. Okay. And then obviously in the middle we have the water. So water moving here, the force of the water is going to erode any material along the bed and the banks. Okay, so that's what we mean by hydraulic action. The next one is abrasion corrosion. This is when the beds and banks are worn down by the river's load. The river throws these particles against the bed banks, sometimes at high velocity. So within the water we've got bits of rock. Now the bits of rock can be different sizes, and when the water moves, it will bash along the different parts. Okay, so it's almost like a scrub and bash, and this is the picture we're going to use to explain what I mean by that. So this girl's obviously drawn on the wall, and to get rid of the crown, the mum is rubbing the brush. That brush is acting as an abrasive way of getting rid of the crown, and it's the same with water. Water's passing through the river, as you can see here, and then what happens, the tiny bits of particles here and here and here actually erode the bed and the banks, and depending on the velocity of the river leads to high erosion. So that's abrasion and corrosion. Then we have attrition. What does attrition mean? So the material load is carried by the river bump into each other, and so smoothed and broken down into small parts. So this is what we're talking about, this little picture here. But what happens, these rock particles hit each other as they bump down the bottom of the riverbed, and what happens, that movement of the water forcing the rock to move and hit another rock, that's called attrition. And then finally what we've got corrosion, which is the chemical action of waters. The acid in the water slowly dissolves the bed and the bank. So this picture here, where we've got obviously the chemicals in the soap powder that keeps the plates clean, and that's what happens. Water is slightly acidic, particularly rainwater, and with more and more human interactions with the atmosphere, the more acidic water is going to be. So that acid in the water, although slight, will eventually erode any chemicals that it reacts with in the rocks. So that's erosion. The next one we're going to look at is, sorry, excuse that one, is transportation. So transportation is the movement of particles down the river. So the first one, we've got traction. Boulders and pebbles are rolled along the riverbed at times of high discharge. Discharge is when the river is carrying a big load. So you will see that sometimes rivers are in flood, the water looks dirty. That's because the water is full of material. So big boulders, that's what traction is. Saltation is sand-sized particles are bounced along the riverbed by the flow of the water. You can't really see them unless you're looking very closely in the water. Then we have suspension. Fine clay and sand particles are carried along the water at low discharges. So that's virtually happening all the time. And then very, very finally, this is what we'll have to do when we measure water using chemicals, is to work out how much has been dissolved. So that's the way rivers and water transports rocks. You've got the big boulders with traction, the smaller bits along the riverbed, saltation, suspension. When you look within the water, you can see the suspension, and then the solution, the diluted aspects of the rock in chemical form. Okay, that's a bit of erosion, transportation. I hope that helped.